Hello friends, I am Dr. Sudhan Sharma from School of Computer and Information Sciences, Indira Gandhi National Open University, and this is our second session in the series of learning linear programming. In our earlier session, we learned about what linear programming is, how to formulate and identify the objective function, what are constraints, how to identify the feasible region, and how to determine the optimal solution. And that was just on the simpler notes, and in this session we are going to attempt some of the rigorous problems. Apart from this, we are going to address the problem of cost minimization by using the technique of linear programming. So, the objectives of the today's session are to solve the linear programming problem and apply the concept of linear programming problem for cost minimization. As we had already emphasized in our earlier session that we are going to explore the graphical method for solving the linear programming, and there are two methods. There is a corner point method and the isoprofit or isocost method. We are going to explore the corner point method, and the steps of corner point method are listed here. Same steps we had executed when we delivered the earlier session, wherein we learned how to determine the objective function, wherein we solved the problem of chairs and tables. So, the corner point method is about to plot the feasible region as the first step, and then we are supposed to find the coordinates of the corner points of the feasible region. After that, we are going to calculate the value of the objective function at each and every point of the corner point in the feasible region. Finally, we are going to pick up the maximum or minimum value of the objective function among the points which are determined at step 3. So, many a time in the examinations or in the assignments also, that is the continuous assessment, the problems are given wherein the directly the objective function and constraints are given to you. Likewise, over here the objective function is 5x plus 2y. We need to maximize this objective function subject to these constraints. There are 4 constraints. So, obviously, by looking at the constraints, you should see that there should be 4 lines, and each line is representing each constraint. So, there are 4 constraints. Yes, you are finding that there are 4 lines also. So, these are the lines, and these lines are represented by equation number 1, 2 and 3. So, 1, equation number 2, equation number 3 and equation number 4, as we had done in our earlier session, that how to determine the point of intersections, that is the x intercept and the y intercept, and by joining the x intercept and y intercept, we are going to draw the lines in between the x intercept and the y intercept. So, we are here to the objective function. The objective function is 5x plus 2y. We need to maximize it, and the first constraint is this is 1, this is 2, this is 3 and this is 4. So, 4 equations are given to us. Now, equation number 1 is minus 2x minus 3y less than equal to minus 6. In when we were dealing with inequalities, we learned that when we are going to handle the negative sign, then the inequality sign is going to change. So, this inequality, which is minus x minus 3y less than equal to minus 6, can always be written as 2x plus 3y, 2x plus 3y greater than equal to 6. So, that means we are now into the situation we can find the x intercept and the y intercept by solving 2x plus 3y equal to 6, 2x plus 3y equal to 6. Substituting x is equal to 0, you can get 3y is equal to 6, wherein y is equal to 6 by 3, that is equal to 2. Substituting y is equal to 0, you get 2x is equal to plus 0 is equal to 6, that is x is equal to 6 by 2, that is equal to 3. So, the y intercept is 2 and x intercept is 3 for the equation 2x plus 3y greater than equal to 6. Now, 2x plus 3y, this is our first equation. So, this is our first equation 2x plus 3y equal to 6 and it is greater than equal to 6. So, region should be on this direction. So, the point of intersection, that is x intercept and y intercept, the y intercept is 2. So, this point is 2 and x intercept is 3, this point is 3. Similarly, you can find the intercept values for this line, that is line number 3, line number 2, line number 4, and because referring to the inequalities which are less than equal to, or you can plot the region. Now, because in equation number 3 the region is, the inequality is, you are having in equation number 3 minus 3x plus 2y is less than 3, is less than. So, less than region should be given in this direction. 6x plus 4y is less than 24. So, 6x plus 4y is less than 24, that means you are getting equation number 2. So, equation number 2 is this, and this is this is going to be in this direction. So, this is rearranged into x. Apart from this, you are going to solve x minus 2y is less than equal to 2. So, x minus 2y, this is equation number 1, equation number 2, x minus 2y is less than equal to 2. So, this is to be direction in this. So, based upon the direction you can find the feasible region, as we had found the feasible region when we solved the problem of tables and chairs. So, this is the feasible region because this is lying in this direction, this is lying in this direction, this equation solution is lying in this direction, for this equation the solution is lying in this direction. So, this direction, this direction, this direction and this direction, as a result of which the feasible region is lying in, this is the section of feasible region. So, applying the understanding of our earlier session that objective function is given to you, constraints are given to you, using the equation of constraints substituting x is equal to 0 and y is equal to 0, you can get x intercept and y intercept. Joining the points of x intercept and y intercept, you can generate the lines. Watching the inequalities, whether it is less than equal to or greater than equal to, you can find the feasible region. And after finding the feasible region, you are supposed to find the feasible solutions. Now, feasible solutions are the point of intersection of the lines which are satisfying the feasible region also. So, over here in this question, the feasible solutions are these 4 points, because these 4 points are enclosing the feasible region. And we learned in our earlier session that in order to find the feasible solution, we need to solve the equations altogether, as if this equation, this point, say this is point A, or this is point B, this is point C, or say this is point D. Then point A is intersection of two lines, that is 6x plus 4y is equal to 24, and that which is this line, which is our this line, and second line is minus 3x plus 2y is equal to 3. So, the intersection of this line and this line is giving you point A, and this line is given by this equation, that is 3x plus 2y is equal to 3, and this line is given by this equation, which is 6x plus 4y is equal to 24. So, solving these two equations, you can get the point of intersection, that is point A, and which turns out to be 3 by 2 comma 15 by 4. Similarly, you can determine other points of intersection. You can determine point B as 7 by 2 comma 3 by 4. You can determine this point of intersection. So, you can determine these point of intersection in the manner as it was discussed in our last session, that by solving the equations of the lines which are intersecting at that point. So, we got 4 intersection points, point A, B, C and D, wherein point A was the intersection of line 1 and 2, B was intersection of line 2 and 3, and 3 and 4 leads to intersection point C, and 4 and 1 leads to intersection of point D. Now, evaluating the profit function, maximization function is 5x plus 2y for these points, So, you will get the profit at point A is 5 into 18 by 7 plus 2 into 2 by 7. Similarly, at point B it will be 5 into 7 by 2 plus 2 into 3 by 4. At point C it will be 5 into 3 by 2 plus 2 into 15 by 4. At point D it will be 5 into 3 by 13 plus 2 into 24 by 13. And it turns out that the profit is maximum at point B, and this profit is of 19 units and occurs at point B, wherein the x value is 7 by 2 and y value is 3 by 4. So, I hope you understand by applying the understanding of the concepts given in the last session that the objective function is given to you, constraints are given to you, non-negative constraints are given to you. Then firstly you are supposed to find the intercepts. So, we learned that in the questions wherein the objective functions are already given to us, the set of constraints are already given to us, the first step is to draw the line segments, and in order to draw the line segments you are supposed to find the x intercepts and y intercepts. After finding the x intercepts and y intercepts, draw the line segments and determine the feasible region by looking at the sign of inequalities, whether it is less than, equal to, or less than or greater than equal to, and identify the feasible region. Thereafter, identifying the feasible region, determine the feasible solutions, which are the points of intersection of the lines. Thereafter, at the point of intersection of line, evaluate the objective function. If the objective is to maximize, then the maximum value, the point at which the value of the objective function maximum is the optimum solution. Otherwise, the point at which the value of the objective function minimum is the optimum solution for minimization problem. Now, herein we solved the problem whose mathematical formulation is already done. In the last session, we had formulated the sentence problem into its mathematical equivalent. Herein we are again going to solve one more word problem, and we give you the stepwise solution, and just follow these steps for every other problem to solve the linear programming problems, and you will find that this way of executing the steps will help you in solving the problems in a better way, because we solved the problem in our earlier session also, wherein we formulated the problem of tables and chairs into its mathematical equivalent and solved the problem, but formally we did not give you the steps. So, over here we are going to provide you the stepwise execution. So, let us come to the problem. The problem is an aeroplane can carry a maximum of 200 passengers. A profit of rupees 400 is made on each first class ticket. So, maximum is 200 passengers is the carrying capacity of the plane. Profit of 400 is made on each first class ticket, and profit of 300 is made on economy class ticket. So, we are having two type of tickets, first class ticket and economy class ticket. As in that case, we were having tables and chairs. Airline reserves at least rupees 20 seats for first class. However, at least 4 times of as many passengers prefer to travel by economy class than by the first class. Determine how many of each type of tickets must be sold in order to maximize the profit. So, objective function is to maximize the profits for the airline. So, what is the maximum profit, and we need to find the maximum profit. So, the first step is to define the variables. So, let x be the number of first class tickets and y be the number of economy class tickets. The objective function is 400 rupees are made, profit is there for first class tickets and 300 rupees for economy class ticket. Therefore, the total profit P will be equal to 400x plus 300y, and this is our objective function, that is P is equal to 400x plus 300y is the profit, is the objective function, and we need to maximize the profits. Now, we need to formulate the constraints. First constraint is the capacity constraint, because the airline can carry at the maximum of 200 passengers. So, that means the first class tickets plus economy class tickets should always be less than equal to 200. At the most 200 passengers can be carried. So, this is the first constraint. Second, the first class seat constraint is there, that airline reserves at least 20 seats for the first class. So, at least 20 seats. So, x is greater than equal to 20 is the second constraint. Third is the preference constraint, wherein it is mentioned that in the question that at least 4 times as many passengers prefer to travel by economy class than by first class. So, that means economy class passengers are greater than equal to 4 times of the first class passengers. And the passengers can never be negative, whether it is of the first class or the economy class. So, x should be greater than equal to 0 and y should be greater than equal to, this is a non-negativity constraint. So, I think you understand that how we defined the variable, how we formulated the objective function, how we identified the constraints. Now, the formulation of the problem, which is our step 4, is to maximize P is equal to 400x plus 300y subject to these constraints. So, this is the mathematical formulation of the problem. Now, step 5 is to solve the linear programming problem, which we had just formulated in our step number 4. So, firstly we need to plot the graph as it was plotted for earlier problem also. Again the same thing, we need to find the intercepts, draw the lines, find the point of intersection, evaluate the objective points at the point of intersection after finding the feasible region. So, plot the constraints. First constraint was x plus y is equal to greater than equal to 200. So, less than equal to 200. So, x plus y less than equal to 200. So, we need to solve the equation x plus y is equal to 200. Now, that means y is equal to minus x plus 200. That means looking at equation y is equal to mx plus c, this equation of line has slope is equal to minus 1 and intercept is equal to 200. So, this is slope is equal to minus 1 and intercept is equal to 200. So, that means x is equal to 20 is the vertical line at x is equal to 20. So, this is the first vertical line, x is equal to 20 will be the first vertical line, and y is equal to 4x is the line for slope 4. So, we are going to have this line y is equal to 4x, x is equal to 20 and x plus y is equal to 200. So, these 3 constraints 1, 2 and 3 leads to 3 equations or 3 lines, that is y is equal to 4x, x plus y is equal to 200 and x is equal to 20. And x is equal to 20 will be the vertical line parallel to y axis, and y is equal to 4x because the slope is positive. So, it will be in the rising direction, and this equation has got slope of minus 1, that is the negative. So, this is going to have the slope in this direction. Now, looking at the inequality, y is greater than equal to 4x and x is greater than equal to 20 and so on and so forth. By looking at the inequality, we need to find the feasible region. So, we find that y is equal to 4x has got region in this direction, x greater than 20 will have region in this direction, and x plus y less than 200 will have region in this direction. So, all these regions, this is in this direction, this is in this direction and this is in this direction. So, as a result of which we are going to have the feasible region is this region. So, this region is our feasible region. Now, in the feasible region we are supposed to find the point of intersection, that is we need to find intersection point this, this and this. So, by solving the equations, that means by solving the equation, say we want to find point A. So, this point, in order to find point A, you need to solve this equation and this equation, that is this is the intersection of x is equal to 20 and y is equal to 4x. So, that means y is equal to 4 into 20, that is y is equal to 80. So, 20 into 80 is point A. Similarly, you are supposed to find other points of intersection. Likewise, point B will be the intersection of these lines, this line and this line. Now, this line, that is x plus y is equal to 200 and y is equal to 4x. So, substituting y is equal to 4x in this, you get 5x is equal to 200. So, x is equal to 200 by 5, that is equal to 40, and y is equal to 4x, y is equal to 4x, that means y is equal to 4 into 40, that is equal to 160. So, B is the point of intersection 40, 160. So, these are the feasible solutions. So, finding the intersection, similarly you can find the intersection of point C and that turns out to be 20, 180. So, you found the points of intersections as 40, 160, 20, 80 and 20, 180. Now, you need to find the optimal solution, that which of these points gives you the maximum profit. So, we evaluated the profit function P is equal to 400 x plus 3, profit function is 400 x plus 300 y. So, profit function which need to be maximized is 400 x plus 300 y. So, for point A, for 40, 160, 400 into 40 plus 300 into 160 turns out to be 64,000. Similarly, at point 2080, this profit turns out to be 32,000. For point 2180, this turns out to be 62,000. So, that means at the point 40, 160, that means at this point the profit is maximum and it is 64,000. So, conclusion is that the maximum profit of 64,000 can be achieved by selling 40 first class tickets and 160 economy class tickets. So, 40 first class tickets and 160 economy class tickets leads to maximization of the profits. I hope you understand how to solve the linear programming problem in a stepwise manner. Now, we are going to address the application of linear programming for the sake of cost minimization, because till now we are only attempting to maximize the profits. Now, in order to understand this, the same concept will be applicable over here, but over here instead of maximization we are going to minimize it. So, for better understanding, let us understand this concept with the help of an example. In this example, a farm is engaged for breeding pigs. The pigs are fed with products grown on the farm, and in view of the need to ensure certain nutrients, it is necessary to buy two products. So, two type of products are there, product A and product B. and the content of the various products per unit in the nutrients, that is vitamin, protein, etc., is given in the table. So, we are having product A and product B, and we are given 3 nutrients. Each nutrient is having these products are having different nutrients. So, we are having, this is the table, we are nutrient content in the product is given as 36 and 6, and the minimum amount of the nutrient required is 108. So, this last column, this minimum amount of the nutrient constituents for M1, M2 and M3. These 3 are the nutrients which must be given to the pigs. If product A and B cost rupees 20 and rupees 40 per unit respectively, how much of these 2 products should be bought so that the total cost is minimized? So, again now over here we need to minimize the expenditure, and it is given that the cost of product A is rupees 20 and cost of product B is rupees 40, and minimum amount of nutrient requirement is given is 108, and the nutrient content in product A for meal M1 is 36, and for meal M1 the product B carrying 6 units of the nutrient. Similarly, meal M2 carries 3 units of nutrient in product A and 12 units of nutrient in product B, and product for meal M3 the product A carries 20 units of nutrient and meal B carries 10 units of nutrient. So, we need to minimize the cost. So, cost function in this case profit function is replaced by cost function. Since 20 rupees is the cost of product A, so say X represents the cost of product A and Y represents units of product B, then the cost function will be 20 units of X plus 40 units of Y. So, this will be the overall cost. Now, the constraints are it's looking at the table, looking at the 36 units are in product A, 36 units of nutrients are in product A and 6 units of nutrients are in product B, and minimum amount of requirement for nutrient as per meal M1 is 108. So, this is expressed by the inequality that 36x plus 6y should be greater than equal to 108 because it is a minimum requirement. Similarly, formulating the other 2 inequalities, 3x plus 12y, 3x plus 12y should be greater than equal to 36, and meal M3 20x plus 10y should be greater than equal to 100. Now, we are having a cost function. In the earlier problems we were having the profit function, now it is the cost function. Earlier problems we are supposed to maximize, over here we are supposed to minimize. We are having constraints over here also, we were having constraints over there also. So, the problem is to minimize, the problem formulation is to minimize the cost subject to these constraints. Now, again the problem, the same mechanism of the solution is to be there. The mechanism is to find firstly the intercepts, and the intercepts that is on x axis and y axis, which is we are going to substitute x is equal to 0, say we are having 36x plus 6y greater than equal to 108. So, this is to be solved for 36x plus 6y is equal to 108. Substituting x is equal to 0, you will get 6y is equal to 108, that is y is equal to 108 by 6. So, and that means similarly for substituting y is equal to 0, you will get 36 into x plus 0 is equal to 108 and x is equal to 108 by 36. So, you solve it and you will get the point of intersection, and you will get different points of intersection will be there. So, 6 1 the 6 plus 6 8 the 48. So, 18 and so y is 18 and you will get point x as 3. So when y is equal to 0, x is equal to 3, which is this point. When x is equal to 0, y is equal to 18, which is this point. So these are the intercepts along x axis and y axis, and this point A will be 0, 18, and this point is 3, 0. And this is for the equation of line 36x plus 6y is equal to 108. That is equation number 1. And since it is greater than, so the region which is satisfied will be towards the right hand side. So that means this will be along this direction. So similarly, you can find the intercepts for other two inequalities, and you will find and draw the lines as we did it for the problem of maximization of the profits. And you will find that since there are three inequalities, you will find that there are three equations, three line segments which are drawn, and each line segment has got different intercepts. Likewise, we determine 18 and 3, you can determine 3 and 12, 5 and 10. So by joining these lines, and because all inequalities are greater than equal to, so this region will be in this direction, this region will also be in this direction, this region will also be in this direction. So the feasible region turns out to be this shaded region. And this shaded region has got the vertices which are given by point A, B, C and D, which are shown over here. This is point A, this is point B, this is point C and this is point D. Point A, now we are going to evaluate, these are the feasible solutions. Now we are going to evaluate the cost function at these feasible points and find the point at which the cost is minimum. So at point A, the cost function evaluates to 720. At point B, the cost function evaluates to 280. At point C, the cost function evaluates to 160. At point D, the cost function evaluates to 240. And it is found that at point C, it is the minimum. So the minimum cost is obtained at point C for x is equal to 4 and y is equal to 2. That is, we obtained the minimum cost by putting the 4 units of content A and 2 units of content B. So this was about the cost minimization problem. So I hope after going through this session, you are able to understand what is linear programming, how we attempted and applied the concept of linear programming to maximize the profits and also to minimize the costs. And this is a very interesting topic you will enjoy by attempting more and more problems given into your self-learning material. Go through the steps which are given in the session and apply these steps while solving the problem given in your self-learning material, and you will gain a lot. Thank you.